number 8 looks like this. Okay, so it's 1 plus tan x over 1 plus cotan x equals 1 minus tan x over cotan x minus 1. Okay, so that's what we want to prove here. Okay, so I am going to work with one side and then I'm going to work with the other and see if we can get them to be equal, and we will see that we probably will. The best way to do these proofs is to start from one side and go directly to the other. But sometimes that's hard to do. So we try it one way and then we figure out something that will maybe make it easier when we refine it. Okay, so start with the left side. Left side is 1 plus tan x over 1 plus cotan x. And I'm going to pick the bottom of this side and I'm going to multiply the top and bottom by that, because eventually that's what I want to get on this side, and see if it works out. If it doesn't, and we have to stop somewhere because we can't see it, well then we stop and we work with the other side. So I'm going to do this do nothing rule. Cotan x minus 1, cotan x minus 1. I'm not changing the value of this side. I'm just multiplying the top and bottom by the same thing. Okay? So when I multiply that out, I'm going to get, I'm just going to leave the bottom. I'm going to simplify the top. So 1 times cotan x, and then 1 times negative 1 is negative minus 1. Tan x times cotan x. Okay, and then tan x times negative 1, so minus tan x. Now, tan x times cotan x, these are reciprocals of each other. This is like multiplying x by 1 over x. That just equals 1. Okay, so tan x times cotan x is equal to 1. Okay, and then this on the bottom is just going to be 1 plus cotan x times cotan x minus 1. Okay, now this is 1. Negative 1 plus 1 is 0. So I'm just going to end up with cotan x minus tan x all over 1 plus cotan x and cotan x minus 1. Okay, so I can't see directly how I can keep going with this, so that I eventually want this just on the bottom here. Okay, but I don't see how I can cancel this out with anything on the top and get 1 plus tan x. There are side things that you can do for that. Okay, but we're now going to go to the right side. Okay, so the right side, going to do the same thing. 1 minus tan x over cotan x minus 1. And I'm going to multiply top and bottom by the bottom of the other side. Okay, so that's the right side. So I'm going to multiply it by 1 plus cotan x and 1 plus cotan x. And I know that by doing this, I will end up with a denominator that's the same as this. And we'll see if the top works out to be the same. Okay, so when I multiply this out, on the top, I'm going to get 1. And then I'm going to get plus cotan x. Okay, minus tan x. And then minus tan times cotan. Okay, all over the bottom. Okay. Now this, again, equals 1. And 1 minus 1 is 0. And we end up with cotan x minus tan x on the top, cotan x minus 1 times 1 plus cotan x on the bottom. Okay? So, and this is the same as what we had up here for the left side. So those two are identical, this and this. So now we can say the right side equals the left side, and therefore left side equals right side, and we're done. Okay? Now there is a way to go directly. Okay, so one of the ways is just to take this proof here and turn it upside down underneath this one. Okay, so you could go and not put this line in, but underneath this one, put this line in, and then put this line in, and then go to the end. So that's one way to sort of cheat and do that. Another way is to notice that if you've got here the part of the denominator that you want to get, you need to cancel this out. Then you know that this should equal, if it's going to work, it should equal on the top 1 plus cotan x, and we want 1 minus tan x. Okay, and 1 plus cotan x and cotan x minus 1. That's what we want this to work out to. So all we've done is change the top. And then if these cancel out, then I have the right side. In fact, this is true. Okay, so the top does equal this. It's not immediately something that you can see, or that I can see anyways, but what you could do is a side proof, make your own little identity on the side and go and multiply this out. When you multiply this out, you're going to get this, okay? And then you can use this as an identity and continue on, okay? So this is a way to continue on with one side. All right. I'm going to do a couple more and then we're done. So now we're going to do a couple more of grade 12 identities. Okay. So here we go. We're going to start off with 11A on the same page. So 11A is cos 2 theta, or cos 2x, say, plus 1 all over sine 2x equals cotan x. Okay, so this is what we want to prove. Obviously the left side's more complicated looking, needs some simplifying. So we're going to try to simplify the left side first. So left side equals cos 2x plus 1 over sine 2x. We're going to substitute our formulas for the double angles. I'm going to put in one where I'm going to get rid of this 1. Okay, so cos 2x, one of our identities is going to be 2 cos squared x minus 1. Okay, so that's the one I'm going to use. I could have used 1 minus 2 sine squared x, but because this is cotan x, that actually equals cosine x over sine x. So I kind of want to end up with a cos on top. So I want to change the cos 2x to something with cos. So I'm going to do 2 cos squared x minus 1 plus 1. And then on the bottom, sine 2x is 2 sine x cos x. So these cancel out. And you end up with the 2's So I'll just write this out again. 2 cos squared x over 2 sine x cos x. Now the 2's cancel out. One of the coses cancel out from the top with the one on the bottom. And now I just end up with cos x over sine x. And that equals cotan x, which equals the right side. And there we are. Left side equals right side. Okay. And that one's proved. Okay, so that's 11a. Now let's take a look at 11c. Okay, so 11c, well, this one is sine x plus cos x all squared. I want to prove that that equals to 1 plus sine 2x. Okay. Well, let's look at the left side here. So left side equals sine x plus cos x squared. And when you square that, you're going to end up with, it's a perfect square, so you're going to end up with sine squared x plus 2 sine x cos x plus cos squared x. Okay. Now sine squared plus cos squared equals 1. So sine squared x plus cos squared x plus 2 sine x cos x. So this equals 1, and this equals sine 2x. So, which is what we want. 1 plus sine 2x. Okay, and that is the right side. Okay, therefore left side equals right side. Okay, and we're now going to do our last proof, which is I. Okay, so 11I. And here we go. So 2 tan x over 1 plus tan squared x equals sine 2x. All right, so we're going to do the left side. 2 tan x over 1 plus tan squared x. Well, the bottom from our Pythagorean identities, this is one that equals secant squared x. So 2 tan x. If that were a minus in there, then this would just be the double angle formula for tan, but it's not, it's a plus. Okay, so 2 tan x over secant squared x. Okay, and secant is just 1 over cos, so I could bring that up there and put a cos there. Okay, so equals 2 tan x over 1 over cos squared x, which equals 2 tan x cos squared x. Okay, now going to come down here. Tan is sine over cos. So 2 times sine x over cos x times cos squared x. This cancels out with one of those. 2 sine x cos x. And this is our double angle formula for sine, which equals sine 2x, which equals the right side. Therefore, left side equals right side. And that's it for trig identities for 4U.